Hi everyone, so let's continue where we left off last time and solve more problems. So I've been using this result to prove things, so might as well prove it right now. So we have the following problem. So 25, which is if A, B, U, and V is in Z, or such that AU plus BV is 1, proves that the GCD between A and B is 1. And then part B, show by example that if AU plus BV is equal to D, which is bigger than 1, then AB may not be D. So, since the question is asking about part B, let's see the main reason for why it doesn't work. So here, remember the GCD between A and B is equal to how we constructed it is equal to the minimum of the following set, where we consider the minimum with respect to positive elements. Set AM plus BN, where AM plus BN is bigger than or equal to 0. And then if you get that one of the combinations is giving 1, then that must be the minimum. That's how we proved it. So that gives a clean proof to the idea. So that's bigger than or equal to 1. So if you represent it as if you have one of the presentation giving 1, then it must be 1. So then you get that if there exists a U and a V inside of Z, then you have n such that AU plus BV is 1, then automatically you get that D is of AB must be equal to 1. Or if you want to be very, very pedantic about it, you have that D is bigger and equal to 1, by assumption, because we know that the GCD of any number is bigger than or equal to 1. But by construction, it is the minimum of the set above. So then that set, one of the elements is 1. So, and we're considering the positive elements. So that means that it must be equal to 1. So, since we are picking the minimum, of the set S, let's call this S, and then that must be 1. All right, perfect. Perfect. So let's see a different way that we could do this. So let D be the GCD of A and B. Then because D divides A and D divides B, then it reaches A and B by some integers. So there exist on R and a K inside of the integers such that D times R is equal to A and D times K is equal to B. So then it follows that you can write in the equations, you can write A as D times R times U, plus writing B as D times K times V, which is equal to 1. So then getting the D out, because KV, you get 1. So then that means that D divides 1. So hence, so it follows that D is less than or equal to 1. Okay, perfect. Perfect. So as you can see, actually, part A really gives us a way to construct for part B, because part A is telling us that D, if you write, if you have, even if you construct a number where you get that is equal to D, then you find, because we cannot express any number as we cannot express any number in terms of D, just like we do with 1. So that means that we don't reach all the numbers. So in particular, we might not reach the minimum possible divisor. So that's one explanation. So the second explanation is that you might reach like a divisor which is not really the minimum. Here 1 works because it's always guaranteed to be the minimum, because it's the first number which is bigger than its first number in Z, which is bigger than 0, as singles follow by increments of 1. So let's see how can we work that out. So show an example that if Yeah, so let's just pick 2 and 4, for instance. Yeah. Yeah, let's just pick A to be 2 and B to be 4, and just consider 1 and U to be 1, and V is 1 as well. So then you can write D, you can write 6 as just 2 plus 4, but 6 is not the GCD between A and B. But you see here that 2 divides the GCD between 2 and 4, which is 2, divides 4. So yeah. So that's the main reason. So let me end the video here and we'll continue in the next one. See you guys.